Okay, so what's some of the things we would use population data for? One of the big things is going to be for managing game species. Recreationally, and historically, humans have been hunters, and we like to make sure that there's enough of the species we like to hunt around, and we like to make sure that we take care of those populations so that way they stay healthy, so that they'll always be around for us to be able to hunt. So if you like to hunt or fish, then you know a lot about how population data is used. Hunting season does not open the same time every year. It does not run for the same length of time every single year. And you cannot take the same exact things one year as you did the year before. Um, all of the data that we collect from populations helps us regulate those seasons. Things like how many does you can take, how many bucks you can take. If you're fishing, what size fish, what kind of fish, what gender of fish is legal to keep and catch. It's important to make sure that you're registered as a hunter and as a fisher, and that you report your catchings to the proper people so they can collect this data so they can actually manage the species. Because that makes a big impact on the health of the population, and a healthier population is something we're going to want. You don't want sick deer running around or scrawny deer because they're starving because there's too many of them. Um, and the same thing with fish, and the same thing with ducks and turkey and every other game species that we use. We also use this information for non-game species as well, things that we don't hunt. But a big one that we come in contact with every day are going to be the game species. So lots of different agencies get that information, and a lot of them government agencies. Some are research-based and science-based agencies using to study populations. So that information comes in really handy. How many, how dense, how are they distributed? Um, but there's other information we can collect too. So when we look at populations, we want to look at generally how is the population growing? Is it going up? Is it going down? And what's the state of it as it does so? So there's a couple of terms we're going to put with this. First is exponential growth, which most of us know from math classes. The rate becomes more and more rapid of growth. And essentially it goes from an almost horizontal line to a vertical line pretty quickly. Essentially a good way to think of this is every time the number doubles. We experience exponential growth in situations where there's a small population, and they're in an area with more or less unlimited resources. If that's the case, if there's no sickness, if there's no disease, if there's no predators, and there's plenty of water, plenty of food and nutrition, plenty of space, plenty of mates, as long as those conditions remain unlimited, the curve, if you were to graph their numbers, it would always go exponentially. But the earth is only so big, land is only so big, ponds are only so big, a habitat can only sustain so much. So we know that we don't often see exponential growth continue on for a long time. But when it does, we call that its biotic potential. What is the potential, the rate for a population to grow at its fastest under kind of unlimited resources conditions? So exponential growth is what it would look like on the graph, but the biological term for that is a biotic potential. But like I said earlier, there's a limit to what habitats can sustain. We call that the carrying capacity. So the carrying capacity would take a exponential growth, the biotic potential of an organism, and start leveling it off, right? At a certain point, resources start becoming scarce. Space, food, water, nutrients, mates, all that starts becoming rare. And so the numbers of the population start to level off. You have more deaths, you have less births, and the number over time starts to level off. And we see that it usually levels off right around carrying capacity, because you can't go above carrying capacity, because then your numbers are greater than what the environment can support. And that's when your population stops growing and it starts to decline. Anything that causes a species' biotic potential to level off at carrying capacity is something we call environmental resistance. Sickness, disease, predation, adverse weather conditions, accidents, all of those things slow down and stop a population growth and cause it to level off. So all those things are environmental resistance, and we usually see that happen right around the carrying, or where that happens, where that the maximum point of the population growth goes. That's usually where we can see that's the carrying capacity of that particular ecosystem for that species. And so usually when we look at stuff, we kind of, this part's already happened, right? We look at a population, and we usually see it right around these ranges, right around the carrying capacity. So what's the difference between biotic potential and experimental resistance? Again, biotic potential is the same thing as exponential growth. When it levels off at carrying capacity, that's because of environmental resistance. So what's something that causes the biotic potential to go up? Well, the reproduction rate is high. They move into, new individuals are moving into your area. If you have really good defensive mechanisms, you're going to have a high population because things won't be able to kill you, and so forth and so on. There's tons of things that could make a species' numbers go up, but what can make them go down? What are some examples of environmental resistance? Well, like I said earlier, lack of food and nutrition, lack of water, lack of suitable habitat, adverse weather conditions, predators, disease, parasites, competition. All of those things are going to slow down a population's growth rate. And where does it level off? Around carrying capacity. Can't really go above that because then you got too many. So it usually levels off right around carrying capacity. So to take all those terms and just put them on a little bit different graph. So you have population. It's got plenty of resources. Its carrying capacity is way it's here. It's not there yet, though. It's just a few individuals. So it's got plenty of resources to go around. It's not crowded at all. It starts hitting by its biotic. It enters into its biotic potential and starts reproducing and growing like crazy. And this is our experimental growth. Once it starts getting close to carrying capacity, it meets environmental resistance. Lack of enough food, lack of enough water, lack of mates. There's going to be competition, right? And predation and disease. And so the population starts to level off. Now, on a kind of like a closer view, the population does go up and down based on the season, because some seasons are good and there's going to be a population boom, and then other seasons are going to be bust and you're going to have a decrease in the population. This constant up and down movement is called oscillation, right? Overall, it stabilizes the population. It just goes up and down and up and down. You can take the average of it and say it's usually right below carrying capacity. But really, you have boom and bust from season to season and year to year. And so that's an oscillation. It just goes up and down a bunch like a wave. So this is normally what we see. This is how we would graph out all this data if we had all this data. So let's look at an application of this. What's something we actually use population growth data in? Well, obviously, like we said earlier, managing game species. So here's our carrying capacity down at the bottom. It's the breeding stock. It's kind of the area where we have enough to support all the way up to this mark, okay? But you can see here, during the springtime, there's lots of vegetation out, lots of berries, lots of fruits are coming out. There's plenty of resources. And so a lot of species have, through evolution, have their giving birth is timed to this time of year, because there's plenty of resources to help get their newborns a good start on life. And so the population, there's a lot of births, a lot of births happening. As we get into summer, there's still a good number of births, but during the summertime, there's less fruit available. There's more green, but there's not as much fruit available. But the population, we're above carrying capacity. So what happens? Starvation starts to kick in. Disease and parasites become rampant. Accidents will start taking down the numbers. And then when we get into the fall, this is where we open up our hunting season. We say, well, how many are left? What's our population like this year? Was it a good year for births? Was it a bad year for births? And then we take that data and we determine how many can be taken during the hunting season, what size, what gender, what's legal to keep, what's not legal to keep. And hopefully this will level it off back down at carrying capacity. Why don't we want it to stay up above carrying capacity? Why is it more better? The environment can only sustain up to carrying capacity. Anything above that is going to be overtaxing on the ecosystem. And we start seeing large populations suffer. I would rather go hunting and shoot a few deer and decrease the population and keep it healthy, rather than seeing a lot of living deer that are sick and starving. So we definitely like, we definitely like this population data, and we like to keep up with it, and we like to help maintain and keep healthy populations of all these different species. So there's definitely good side to hunting. Not as many people hunt nowadays as they used to. I'm not a big hunter. When I was young, I shot a squirrel and it blew its nose off, and I was traumatized. I just watched it basically, suffocate on its own blood. It was terrible. I know it's kind of funny to say, but it happened. I was 6. I didn't know what to do. My dad just stepped on it and killed it, and it kind of freaked me out anymore. So I don't hunt. But I love deer meat, and I love eating. I just love food in general. So my dad will shoot the deer, and I'll clean the deer. That was our deal, or that was our agreement. And so I'm not against hunting at all, because it helps maintain the populations. Now, I'm against overhunting. I'm against unregulated hunting. I don't like dog hunting, because I grew up in the woods, and I've many hunting dogs I've hit in my lifetime that just run out in the middle of the road at nighttime. Too many. I don't like dog hunting all that much. But I like bow hunting. That's nice. That's a skill. So if you're a bow hunter, good for you. But all of that data is used to manage these species, and I hope you see that it actually really, really helps maintain a healthy population, simply because resources are not unlimited. Environments and ecosystems and habitats can only support so much. And that's going to be really important when we start looking at human populations, because there's a lot of us and our numbers just keep growing. So see you next time.